learned about C's relational operators and logical operators. We're going to start using those operators in decision control statements. In particular, we're going to talk about conditional branching statements, if and switch statements. We want our programs then to make decisions. All programs without selection statements just execute one line after the other in sequential order. And we've been writing all our programs with just the main function, and we saw that one line after the other executes. Well, now we'll branch around some of those statements. Some may execute, some may not execute based on some decision tests that we'll make. So we'll talk about, like I said, conditional branching and unconditional branching. Those are the two main types of decision control statements. All right, we want to concentrate on conditional branching statements. We don't want to use unconditional branching statements. We'll talk then about, first of all, the if statement. Then we'll talk about the if-else, if-else-if statements, and the switch statements. We're going to then start with the simplest of the decision makers, the if statement. So a new C keyword, if, will be added. Right. We want to look at this flow chart. It depicts program flow. The way the conditional statement works, the if statement, is think of your program as executing lines above this arrow. The flow then says the next statement to be executed is some sort of conditional test. So this diamond in this flow chart indicates a test. Right? And when the condition in that test is true, we follow the arrow down here and take some action. So basically we're going to say, if this condition is true, do the following. Else, if the condition isn't true, we're just coming down here, our control flow. So we'll branch around this statement. The statement will not execute. This action will not execute when this test is false. We'll come down here and execute some code. All right. So the general syntax then of an if statement, keyword if, the condition we're going to test, so this test expression goes inside parentheses. You always need the parentheses there. The way this works, if this test expression is true, then we will execute these statements found within these curly braces. So this curly brace denotes the beginning of the section of statements you want to execute when the test condition is true. So if the test condition is true, we'll execute statement 1, statement 2, statement 3, all the way down to statement n. We can have one or more statements in between these two curly braces. When this is done executing, then we'll go on and do statement X. So just like the flow chart shows, we come in here, we do the test expression. If the test expression is true, we perform this statement block. So this is known as a block of code. This left curly brace starts a block of code. This right curly brace ends a block of code. So when it's true, we'll do those statements, and then we'll go ahead and execute statement X. But when the test condition is false, we skip over these statements. So we won't execute statement 1, statement n. We'll skip over it, we'll branch over it, and come down here and execute statement X. Once again, just to remind you, the keyword is if. We always have a test expression. It can be simple or complex. It needs to be inside parentheses. Right? We can then execute one or more statements, actions that we want to perform when this expression is true. Those statements go inside curly braces. There is an exception I can show you. If we only want one statement, we don't need the curly braces. We'll see an example in just a bit. When this is false, remember we skip over this block and we go down and execute to statement X. All right. So in the example code I've given you, example 6, we're going to run through that and see the order of execution. Right, I've got the code here and the program output. I'm just going to switch over to code blocks right now. And we're going to see that code execute here. All right, now I'm just going to go ahead, and I haven't built this yet. I'm going to clean the workspace from earlier. I added this file to the project. All right, I just want to say build. Let's just go ahead and step through this. I'm going to say run to cursor here. All right. But what's happened is run to cursor said run all the lines before this. So the first thing that happened is we declared a variable named X. We assigned the value of 9 to its memory. We declared y as an integer type, assigned the value of 10 to its memory as well. The next statement that executed then was the printf statement. It just printed out this message, example 6, simple if statements. So let's come down here now and evaluate this condition. Now we're going to say if x is less than y. Well, is this true? It's going to compare 9 less than 10. 9 less than 10. That's true. Because this test condition is true, we're going to come into this block of statements here. There's only one statement, and we'll execute then that one statement. So let's use the debugger to actually perform the next line. Because this was true, we can see that we came into this block of code. Right. We'll tell it to go ahead and perform that printf. And we see that come up on the screen. That message then, x less than y is true, prints on the screen. Now we're down here to test this condition. We're testing to see if x is greater than y. Well, this will be false, right? 9 is not greater than 10. So remember, false evaluates to 0. If 0 is false, we will not execute this code. So if we say debug, and I say, well, perform the next line, it performs this comparison. Notice it jumps over this. This was false. This statement is not executed. And here, if I just go ahead and say perform that next line, right, it'll print out end of line. So we can see, or end of program, we can see then our program output was just these 3 lines. Right? And then we could let it finish running. I'm just going to stop the debugger. Well, that's the example of a simple if statement. We tested one condition that was true, another that was false, so that we could see the order of execution. All right. Now, let me show you something else. If we take these curly braces away, and I've got another example elsewhere, let's take these this curly brace away, this curly brace away. And it doesn't really matter if there's white space in here or not, so I'll leave it here. By convention, any statements that are associated with an if statement, we always indent. We always indent the blocks of code that execute when a condition is true. It makes it easier to read. Now, C doesn't care whether or not we indent this. This will still execute when this is true, even without the curly braces. So by default, whenever we don't have the curly braces, the one statement, so here's the one statement following this test condition, will execute only when this is true. So let's just go ahead and rebuild this. And let's do a run to cursor again. So it's the same program without the curly braces. Run to cursor. All right, you can see we have our values of x and y here. All right, I'm going to say, let's go ahead then. This should be true. So next line. A condition was true, so it goes down and executes this next line. Right, next line. And you can see then we have the message pop up on the screen. It printed out x less than y is true. This one will be false, so it will skip over this statement. So debug, next line. That was false, it skipped over this statement, right? And if I say debug, go ahead and finish up the program, right? It printed out end of program, and we got the same output as last time. You really can't go wrong by putting these curly braces in here. These really indicate the start of the body of the statement block. So start of a statement block, end of a statement block. Right. Then all the statements in here execute when this condition is true. This is a little more clear. You don't have to remember that. Like I said, if you only have the one statement you want to execute when a condition is true, you do not need the curly braces. I would suggest as a beginning programmer, you always put the curly braces in there to make it very clear what you want to execute when something is true. All right, let's just come back to here. All right, and there's the example output of that program as well. So here's what I was just saying about an if statement with no curly braces. Omitting the curly braces after the test expression causes only the one C statement following the test expression to execute. This is important. As a matter of good programming style, indent the statements to be executed when the test condition is true. You want to follow good programming style. In our class, if you don't do this, this will tend to lose you style points on your homework. Right? It makes it easier for you to read, makes it easier for anyone who needs to help you to read it as well. And when you're working, it makes it easier for anyone in your shop who has to maintain it. Easier to read and know what you meant. All right, well, let's go ahead and look at examples 7, 8, and 9. Here's example 7. If we run this program and we want to try to figure out what the output is, well, we look at this line of code will execute. So we'll see example 7 in the output, which you see right here. The next line of code that executes is this statement, if 9 is less than 10. Well, this will be true. You can see here I've indented the one statement that's associated with this action. So when this action is true, I wanted to print out the message x less than y is true. We see that we get this in the output. That is true. Then we just drop down here and we print out statement A, and then we print out end of program. I just put a couple extra statements in here so you could see the flow of execution. I've also given you example 7 as well. All right, so you should go ahead and run that and step through in your debugger and see how that one works. Let's look at example 8. So example 8, then, right, we're going to see the message example 8 print out, which we see right here. Then we'll check the condition if 999 is less than 1. Well, this condition is false. We'll skip over this block of statements. No execution of this, no execution of this. So what we see in our output is simply example 8, then end of program. These two printfs don't execute because this condition was false. Notice here, both of these statements are associated with this simply because they're enclosed in the curly braces right after the test condition. In the previous example, right, we only wanted one thing to happen when this was true, so we had the one statement here without curly braces. As I said, again, you might want to put curly braces as a beginning programmer so that you make your intentions clear. Okay, example 9. When this code was run, this is an example of a common error that you'll make. Right, let's look at this. First thing that's going to happen is we're going to print out the words example 9, which we see in the output. But a common error you'll first make is putting a semicolon after this test condition. Right, at this point, you're learning to type semicolons at the end of C statements, but this is some new syntax. We do not put a semicolon here. What happens is this is actually a no operation statement. It's a legal C statement. So if you put a semicolon here, this statement will execute, this no operation, which basically does nothing, will execute whenever this test condition is true. Right. And then because if this test condition is true, it would cause these statements to not execute. Let me say this again. Let's look at this test condition. We know this test condition will not be true. It will be false. If 99 is less than 1, that should be false. But because this is the only C statement associated with a true action, we will see this printf execute and this printf execute. But look at the output from this program. The output says 999 less than 1 is true. Well, we know that not to be true. It's because we put this semicolon here. Right, let's go ahead and bring example 9 up in code blocks and run it. Okay, I'm just going to shut this down. I don't want to save that. Let's go to example 9. Right. Let me just remove 6 from the project. Let's add 9 to our project environment. Right. I'm going to just build this, and let's watch this run. Right. Now run the cursor. It's going to execute all the code right up until the first if statement. So we see the example 9 prints out on the screen. But look, this was false. You're probably saying, why are we in here now? This condition was false. Well, we're in here because this semicolon is the only C statement associated with a true condition. So when this is false, we still drop into this code. Right? So if we go ahead and say, well, let's execute the next line, now print out Let's execute the next line. That will print out. And you see we get this in the output. All right, let's stop the debugger. And let's see what happens if we remove this semicolon. Now, when we remove the semicolon, both of these statements are associated with a true action. This will not be true. We will not see these print out, and we'll just see example 9 and end of program print out. Let me just rebuild that. All right, let's run the cursor here. So we see example 9, that statement executed. All right, it skipped over this. It said that this is false, so don't do this, right? The next line it's waiting there to execute is that end of program, right? Removing the semicolon then got rid of that error. So that's a logic error. I'm going to leave that example intact. You will do that from time to time. So whenever you start getting output that you don't expect from an if statement, check to make sure you have not placed a semicolon here. Right? You don't want to do that. Okay, let's talk about compound test conditions. We were only testing one set of relational conditions, but now we want to test multiple conditions, and this is where we start using those logical operators. Right. So if we have three integer variables, x, y, and z, and we want to test, we want to know whether or not x is less than y and y is less than z. Let's take our clue from this word and here. In mathematics, we could write, well, x is less than y and y is less than z. That makes it true that x is less than y and y is less than z. It also makes it true that x is less than z, right? And by a transitive property, in math, you would assume that. Since x is less than y and y is less than z, we would say by transitivity that x is less than z as well. Well, in mathematics, it's okay to write this, but remember, in C programming, we don't write this. Now, let's take a look why. We're going to use the and operation, so the double ampersand, in place of this English word and here. So let's look at this relational expression, x less than y and y less than z. What will that evaluate to? Well, if x is 4 and y is 5, 4 is less than 5. That is true. So this expression will evaluate to true, but y less than z is false. We had to go ahead and check this. No short circuit evaluation there, right? We knew in this case this was true for an and expression for all of the outputs to be true. All of the inputs must be true. So in this case, then we need to check to see, well, is y less than z? No, it's not. So the whole expression evaluates to false. Now, what if we wrote it like this? What if we wrote x less than y less than z? This is going to evaluate to true. Right? Let's take a look at y. Well, x less than y is 4 less than 5. 4 less than 5 is true. This evaluates from left to right. 4 less than 5 is true. So this returns the value of 1. Is 1 less than 2? 1 is less than 2. This evaluates to true. We don't want to write this in C because our goal was to test whether or not x was less than y and y less than z. This is how we write this. We can see we wanted this to be false because y is not less than z. But here, writing the expression like this gave us a value of true. This is why I have in bold, you do not want to write C relational expressions in this form. You use the logical operators whenever you have multiple or compound test conditions. It's the safest thing to do, the best programming practice. Right. Now let's take a look at this. What if we want to count the number of kids in the age range 0 to 11? Well, we could go, all we know is to go through then and check then, because we have a range, each end of the range. So we can say if 0 is less than or equal to age, and age is less than or equal to 11, we know then that it's true, they're in the range of 0 to 11, right? And then we're going to add 1 to our count of kids. So that lets us test a range of numbers. So generally when you're testing a range of numbers and you're using an if statement, you will use a compound condition. Right? Here we can use the OR operator. What if we want to print out the message 30 days for all months that have 30 days? Well, there are several months that have 30 days. There's April, which is month 4. There's June, which is month 6. September is our month 9, and November is month 11. But we say if the month is equal to 4. So if the month is April, we print out 30 days. Or if the month is June equal to 6, print out 30 days. Or if the month is equal to 9, September, print 30 days. Or if the month equals 11, so double equal sign, remember that's our relational operator for equality, we print out 30 days. All right, we need the OR condition because if any one of these is true, we want to print out the message 30 days. All right, once again then, compound statements. Start them with a left curly brace and then with a right curly brace. This is a block of statements. So whenever you want to execute multiple statements, you have to use these. Remember, by default, only one statement is associated with a true condition if you do not use these. So here's an example then, right, where we could print out statement 1, statement 2, statement 3 when a condition is true. Notice here I've just used 1. This test condition would always be true. But we wouldn't necessarily write code that said if 1, right? Since that's always true, we'd always have this happening. This is just an example to remind you to use the compound conditions. Right. Now we can do nested if statements. So we can have an if inside of an if. Well, let's look at this condition. This says if x is equal to 3. So when this is true, then we go evaluate if y is not equal to 6. Both of these conditions have to be true. X has to be equal to 3 before we evaluate this. So if x is the number 2, as soon as this is false, we skip over all of this and would execute any code underneath, right? Because this is the one statement associated with x equals 3. Okay, so as I said, these statements inside here will only execute when x is equal to 3 and y is not equal to 6. We could rewrite that in this fashion. We could rewrite if x equals 3 and y not equal to 6, perform the following. Right? You can write it either way that makes sense to you, whichever way is easier for you to read. These are our equivalent pieces of code. Right. Just to mention again about the common errors that you'll have with the equality comparison, remember that equality operator is the double equal sign, not the single. The single equal sign is our assignment statement. Now let's look at this example with a reminder that an assignment statement has what we call a side effect. A side effect is that it will change memory contents. That's its side effect. So if you were to write a statement like this, if x assign the value of 2. So what happens here is this doesn't compare to see if x is equal to 2, not with just one equal sign. This actually assigns the value of 2 to x, so it will change what's stored in x's memory. And then remember, the result of this expression evaluates to the number 2. So this is like saying if 2. And we learn that any non-zero expression is true, so then it will go ahead and assign 5 to y, because this expression will always be true every time this code runs. So always be careful to use your double equal sign when comparing. If you're getting some logical errors you don't understand, go back and check your test conditions. All right, so we can do a practice exercise now. Right. What if we wanted to write a program that determines whether a person is eligible to vote? That's the problem statement. Write a program that determines whether a person is eligible to vote. Well, then we need to ask, what's the criteria in order for somebody to be old enough to vote or eligible to vote? right? What's the criteria for eligibility? It doesn't have to be age. Well, here's our list of questions to answer, right? Criteria for voter eligibility. Well, we're going to say they must be at least age 18 to vote. And then we start asking ourselves, well, what input does the program need? Remember, most of our programming models are input, process, output. But what input does it need? Well, the program needs to know the age then, since that's a criteria for voter eligibility. Right? And then we ask, well, how will our program get that input? Well, we're going to get it from the user typing at the keyboard, right? If we were to store something in age, we'd always have the same value stored every time, and our program would always give the same results. So we want the user to be able to type in or enter information into the program. And then let's think about the program output, right? We want to see a message then. For everyone ages 18 and above, we'll just have a message saying whether or not the person's eligible to vote, right? No output at all for age is less than 18. So what we're saying is when they're eligible to vote, when they're 18 above, we might just print out a message saying you can vote. But if they are less than 18, our program will have no output. All right, let's take a look at then how we're going to write a C program to do that. We sort of came up with our algorithm back here. Implicitly, we define what needs to go into our algorithm by answering these questions. These are the questions that should have come up in your mind. And then we can take this and start thinking about what order of operations do we need to happen. Well, if we think about the fact that our model is input, process, output, we need to get the information. Right? Well, here's our simple algorithm. We want to read the user age from the keyboard input, and then we want to check, is the age entered at least 18? When that's true, we want to display a message, you're eligible to vote, and then our program stops. So here's our algorithm, fairly simple. Well, now we want to turn it into C code. So we ask ourselves again, how will our program get the user input? Well, we said from the keyboard, and we know that we have a function scanf that reads information from the keyboard. Right? It's going to store the information in a variable, but we will need to declare a variable to store that age information. Right? So if we were start writing a program, then once we defined these necessary actions, we could start writing the C code to do this. Right? So we include the standard I/O library because we're going to use scanf and printf. We've declared a variable here to store their age. Right? We are nicely printing out a message to the user telling them what we want them to do. So enter your age, and then we're going to read in whatever the user types from the keyboard and store that in the variable age. Right? So if we just ran that much of our code so far, we would be able to get our program input. The next thing our algorithm asked us to do, though, was to compare the age to are they at least 18, make that determination, right? Is age entered at least 18? And then we said, yes, when that's true, we want to display a message. When it's false, we display no message. So down here, we have this code. If age is greater than or equal to 18. So when this test condition is true, we'll print out this message, you are eligible to vote. But notice there is no action when it's false. We just simply come down and end the program. Right. What we'll learn about next is an else clause, or the branch we want to take. We might have something we want our program to do when we have a false condition.